Power interruption is a key safety feature for preventing machinery like grinders or other plug-in devices from unexpectedly restarting after a power outage. Several solutions exist to address this issue, including specialized receptacles, power strips, and uninterruptible power supplies, or UPSs. Firstly, let's consider receptacles with power interruption capabilities. The Cooper wiring device's interlock receptacle features a mechanical interlock that trips and interrupts power when the supply voltage drops below a predetermined level. This design prevents devices from restarting automatically when power is restored. Secondly, the pass and seam or alternating current quiet power receptacle is similar to the Cooper receptacle, offering power interruption to prevent devices from re-energizing after a power outage. These receptacles are designed to enhance safety by ensuring that equipment remains off until manually restarted. Now, let's examine power strips with power interruption features. The APC Surge Arrest power strip with power failure indicator detects power outages and cuts power to devices, preventing them from turning back on prematurely. It includes a power failure indicator light to alert users to power loss. This visual cue is beneficial for identifying power interruptions and ensuring that devices are not left running unattended. The Trip Light Surge Protector power strip with automatic reboot is similar to the APC power strip but has an added feature. It automatically reboots connected devices when power is restored after a certain time delay. This can be useful for equipment that benefits from automated restarts while still preventing immediate and potentially hazardous restarts after brief power flickers. Next, we will discuss uninterruptible power supplies with power interruption capabilities. A CyberPower PFC Synwave UPS provides power backup and surge protection. It can be programmed to automatically shut down connected devices during power outages and restart them when power is restored, which prevents accidental restarts. This level of control is essential for maintaining stable power conditions and protecting sensitive equipment. Another UPS option is the Eaton 5 SE UPS, which has the ability to control power output and prevent devices from restarting after power interruptions. It offers customizable settings for shutdown and restart parameters, allowing users to tailor the UPS behavior to their specific needs. When selecting these devices, several additional considerations are important. Firstly, check the wattage rating of the receptacles, power strips, or UPS to ensure they can handle the load of the connected devices. Overloading these devices can lead to malfunctions or safety hazards. Secondly, consider the criticality of the devices to determine the best power protection solution. Critical equipment may require a UPS with advanced features, while less critical devices might be adequately protected by a power strip with power interruption. In addition to these devices, it is essential to implement additional safety measures. Firstly, train employees to turn off devices before leaving work. This simple practice can prevent unexpected restarts and potential accidents. Secondly, install lockout-tagout procedures to prevent unauthorized access to the power system. Lockout-tagout ensures that equipment remains de-energized during maintenance or repairs. When evaluating specific products, here are some detailed technical aspects to consider. Firstly, examine the voltage and current ratings. Ensure that the receptacle, power strip, or UPS is rated for the voltage and current requirements of the connected devices. For example, if you are using 120 volts alternating current devices, the protective device must be rated for 120 volts alternating current or higher. Secondly, check the surge protection capabilities. Look for devices that offer robust surge protection to safeguard against voltage spikes and surges. A good surge protector should have a high joule rating, indicating its ability to absorb energy from surges. Thirdly, review the response time. The response time of the power interruption feature is crucial. A faster response time ensures that power is cut off quickly during an outage, minimizing the risk of unexpected restarts. Fourthly, consider the noise filtering capabilities. Some receptacles, power strips, and UPS offer noise filtering to reduce electrical noise and interference, which can improve the performance of sensitive equipment. Fifthly, evaluate the ease of installation and use. Select devices that are easy to install and configure. with clear instructions and user-friendly interfaces. This will save time and effort during setup and maintenance. Sixthly, check for certifications and compliance. Ensure that the devices meet relevant safety standards and certifications such as Underwriters Laboratories or Canadian Standards Association. This indicates that the products have been tested and meet established safety requirements. Seventhly, consider the warranty and support. Look for products with a good warranty and reliable technical support in case of issues or questions. Eighthly, review the energy efficiency. Choose energy-efficient devices to minimize power consumption and reduce operating costs. Apps, in particular, should have high efficiency ratings to reduce energy waste. Ninthly, evaluate the physical design. Consider the physical size, shape, and mounting options of the devices to ensure they fit well in the intended location. Tenthly, check for remote monitoring and control features. Some UPS offer remote monitoring and control capabilities, allowing users to monitor power conditions and manage devices from a remote location. Let's delve deeper into specific product features. For receptacles, consider the following aspects. Firstly, look for tamper-resistant receptacles, especially in areas accessible to children. Tamper-resistant receptacles have internal shutters that prevent the insertion of foreign objects. Secondly, check for weather-resistant receptacles for outdoor applications. Weather-resistant receptacles are designed to withstand exposure to moisture and other environmental elements. Thirdly, evaluate the wiring options. Ensure that the receptacle has appropriate wiring options for the intended installation, such as side wiring or back wiring. For power strips, consider these additional features. Firstly, look for power strips with overload protection. Overload protection prevents the power strip from overheating and potentially causing a fire. Secondly, check for power strips with angle plugs. Angle plugs can help to save space and prevent cords from blocking other outlets. Thirdly, evaluate the cord length. Choose a power strip with a cord length that is appropriate for the intended application. For UPSs, consider the following technical details. Firstly, review the battery capacity. The battery capacity of the UPS determines how long it can provide power during an outage. Choose a UPS with a battery capacity that meets the needs of the connected devices. Secondly, check the output waveform. Some UPS produce a sine wave output, which is ideal for sensitive electronic equipment. Others produce a simulated sine wave output, which may be suitable for less sensitive devices. Thirdly, evaluate the transfer time. The transfer time is the time it takes for the UPS to switch from mains power to battery power during an outage. A shorter transfer time minimizes the risk of interruption to connected devices. Fourthly, consider the communication ports. Some UPS have communication ports, such as USB or serial ports, which allow them to communicate with computers and other devices. Fifthly, review the software capabilities. Some UPS come with software that allows users to monitor power conditions, configure settings, and perform diagnostics. Now, let's consider some specific scenarios and applications. In a workshop or garage, power interruption devices can prevent grinders, saws, and other power tools from restarting unexpectedly after a power outage. This can help to prevent injuries and damage to equipment. In an office environment, power interruption devices can prevent computers, printers, and other electronic devices from restarting automatically after a power outage. This can help to prevent data loss and system crashes. In a laboratory setting, power interruption devices can protect sensitive scientific equipment from damage due to power fluctuations. This can help to ensure the accuracy and reliability of research results. In a home setting, power interruption devices can prevent appliances, such as refrigerators and freezers, from restarting unexpectedly after a power outage. This can help to prevent food spoilage. Let's also consider some common misconceptions about power interruption devices. Firstly, some people believe that surge protectors provide adequate protection against power outages. However, surge protectors only protect against voltage spikes and surges, not power outages. Secondly, some people believe that all UPS are the same. However, UPS vary in terms of battery capacity, output waveform, transfer time, and other features. Thirdly, some people believe that power interruption devices are only necessary for critical equipment. However, power interruption devices can also be beneficial for less critical equipment to prevent unexpected restarts and potential damage. In addition to the devices and measures discussed above, it is also important to consider the electrical infrastructure in the building. Firstly, ensure that the wiring is up to code and in good condition. Faulty wiring can increase the risk of power outages and electrical hazards. Secondly, install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock, such as bathrooms and kitchens. GFCIs can quickly cut off power in the event of a ground fault, preventing serious injuries. Thirdly, consider installing a backup generator for prolonged power outages. A backup generator can provide power to essential equipment and appliances during extended outages. Finally, remember that power interruption devices and safety measures are only effective if they are properly installed and maintained. Regularly inspect the devices and wiring to ensure that they are in good working order. Replace any damaged or worn components promptly. Train employees and family members on how to use the devices and what to do in the event of a power outage. By taking these steps, you can create a safer and more reliable electrical environment. Let's further discuss the technical specifications of the suggested devices to ensure informed decision-making. When selecting receptacles with power interruption, consider the following. Firstly, the trip voltage. This is the voltage level below which the receptacle will interrupt power. Ensure this level is appropriate for your equipment to prevent nuisance tripping. Secondly, the reset mechanism. Some receptacles require manual reset after power restoration, while others reset automatically. Choose based on your operational needs. Thirdly, the contact rating. Verify the receptacle's contact rating in amps to ensure it can handle the maximum current draw of the connected equipment. For power strips with power interruption, consider these factors. Firstly, the surge suppression rating. Measured in joules, a higher rating indicates greater protection against voltage spikes. Secondly, the number of outlets. Select a power strip with enough outlets for all your devices, but avoid overloading it. Thirdly, the cord gauge. A thicker cord gauge, indicated by a lower American wire gauge number, provides better current carrying capacity and reduces the risk of overheating. When choosing a UPS with power interruption capabilities, consider these technical specifications. Firstly, the volt amp or voltamps rating. This indicates the maximum apparent power the UPS can supply. Ensure it exceeds the total voltamps of your connected equipment. Secondly, the wattage rating. This specifies the real power the UPS can provide. It should be greater than the total wattage of your connected devices. Thirdly, the battery type and lifespan. Lead-acid batteries are common, but lithium-ion batteries offer a longer lifespan and better performance. Fourthly, the output voltage regulation. A tighter regulation, expressed as a percentage, ensures a more stable voltage supply to your equipment. Fifthly, the communication interface. Universal Serial Bus, or USB, and serial ports allow the UPS to communicate with computers for monitoring and control. In addition to these device-specific specifications, consider these general factors. Firstly, the environmental conditions. Ensure that the selected devices are suitable for the temperature, humidity, and dust levels of the environment in which they will be used. Secondly, the regulatory compliance. Verify that the devices comply with relevant safety and electromagnetic compatibility standards, such as Underwriters Laboratories 1449 for surge protective devices. Thirdly, the maintenance requirements. Understand the maintenance requirements of the devices, such as battery replacement for UPS, and factor these into your long-term cost analysis. Let's consider some advanced features that may be beneficial for certain applications. For receptacles, consider smart receptacles that can be controlled remotely via a smartphone app. This allows for convenient power management and scheduling. For power strips, consider metered power strips that provide real-time monitoring of energy consumption. This can help to identify energy waste and optimize power usage. For OPSs, consider network manageable UPS that can be monitored and controlled over a network. This allows for centralized power management and remote troubleshooting. When implementing power interruption solutions, consider these best practices. Firstly, conduct a thorough power audit to identify critical equipment and their power requirements. This will help you select the appropriate devices and design an effective power protection strategy. Secondly, label all power interruption devices clearly to indicate their function and purpose. This will help prevent accidental tampering and ensure that they are used correctly. Thirdly, develop and implement a written power outage response plan. This plan should outline the steps to be taken during a power outage, including shutting down equipment, backing up data, and notifying relevant personnel. Fourthly, conduct regular drills to test the power outage response plan and ensure that everyone is familiar with the procedures. Fifthly, document all power interruption devices, their locations, and their maintenance schedules. This will help ensure that they are properly maintained and that they are replaced when necessary. Sixthly, keep spare power interruption devices on hand for quick replacement in case of failure. This will minimize downtime and ensure continuous operation. In addition to these technical and operational considerations, it is also important to address the human factors involved in power interruption. Firstly, provide adequate training to all employees on the proper use of power interruption devices and the power outage response plan. Secondly, encourage employees to report any power-related issues or concerns promptly. Thirdly, create a culture of safety that emphasizes the importance of power interruption and other safety measures. By addressing both the technical and human factors, you can create a comprehensive power interruption solution that effectively protects your equipment and personnel. Now let's discuss some emerging trends in power interruption technology. Firstly, the increasing use of solid-state relays in power interruption devices. Solid-state relays offer faster switching speeds, longer lifespan, and greater reliability compared to traditional electromechanical relays. Secondly, the integration of power interruption devices with building management systems. This allows for centralized monitoring and control of power distribution throughout a building. Thirdly, the development of self-testing power interruption devices that automatically test their functionality and alert users to any issues. Fourthly, the growing use of artificial intelligence and machine learning in power interruption systems. This enables predictive maintenance and optimized power management. By staying abreast of these emerging trends, you can ensure that your power interruption solutions remain effective and up-to-date. Let's explore how to troubleshoot common issues with power interruption devices. Firstly, if a receptacle with power interruption is not tripping during a power outage, check the trip voltage setting and ensure that it is properly adjusted. Also, inspect the receptacle for any signs of damage or wear. Secondly, if a power strip with power interruption is not cutting off power during an outage, verify that the power failure indicator light is working. If not, replace the power strip. Also, check the surge suppression rating and replace the power strip if it is expired. Thirdly, if a UPS with power interruption is not providing backup power during an outage, check the battery charge level and replace the battery if necessary. Also, inspect the UPS for any error messages or alarms and consult the user manual for troubleshooting steps. In addition to these device-specific troubleshooting tips, consider these general tips. Firstly, use a multimeter to test the voltage and current at the power source and the device being protected. This can help identify any electrical issues that may be causing the problem. Secondly, check all wiring connections to ensure that they are secure and properly installed. Loose or corroded connections can cause power interruptions and other problems. Thirdly, consult with a qualified electrician if you are unable to resolve the issue yourself. A licensed electrician can diagnose and repair complex electrical problems safely and effectively. Let's consider the long-term cost of implementing power interruption solutions. Firstly, the initial cost of purchasing the devices. Secondly, the installation cost, which may include labor and materials. Thirdly, the maintenance cost, which may include battery replacement and repairs. Fourthly, the energy cost, which may be affected by the efficiency of the devices. Fifthly, the downtime cost, which is the cost of lost productivity due to power outages. Sixthly, the equipment damage cost, which is the cost of repairing or replacing equipment that is damaged by power surges or outages. By considering all of these costs, you can make an informed decision about the most cost-effective power interruption solution for your needs. And remember to consult the most recent version of the National Electrical Code, or NEC, for requirements in your specific location. For example, NEC Section 310.15 covers ampacity calculations for conductors, and NEC Table 310.16 provides ampacity ratings for various conductor types and sizes.